So let's go over our law of sines. So we begin with our general triangles. So we have angle A with side A being opposite that, angle B with side B being opposite that, and angle C with side C being opposite that. Now the thing to remember with the law of sines is that it works for any triangle and not just for right triangles. So what is the law of sines? Well, the law of sines says that the sine of angle A over side A is equal to the sine of angle B over side B, and that's also equal to the sine of angle C over side C. So when we're using the law of sines, we usually encounter three situations in which the law of sines is applicable. One situation is where we are given the angle, a side in between, and another angle. So our angle, side, angle. The angle, side, angle situation always leads us to only one solution. Then we have another situation where we know an angle, another angle, and then the side not between them. And that's our angle, angle, side situation. Again, this will lead us to only one solution. And then the third situation, we know two sides and some other angle. This side-side angle situation will lead us to three possible cases. We could either have one solution, we could have two solutions, or we could have no solution whatsoever. So we'll take a look at that particular case in a little bit more depth. Okay, so let's start looking at our law of sines. So we'll take problem 2, where we're given the law of sines, and this is the angle, side, angle case. So we're given a triangle where we're given that angle B is 45 degrees, angle C is 58 degrees, and side A is 14 degrees. So we are in angle, side, angle. So for angle A, we use the fact that the sum of the angles of any triangle is going to be 180 degrees, so that A plus B plus C is 180. So plugging in the values that we know angle B is 45 degrees, we know angle C is 58 degrees, and so that means angle C has to be 77 degrees. So that part was kind of easy. So now, what about finding the sides? Well, now we're really using the law of sines, where we know that the sine of 77 degrees, so that's side A, or angle A, so we know that the sine of 77 degrees over the length of side A, 14, is equal to the sine of 45 degrees over the length of side B. So if we solve this for B, we see that B is going to be equal to 14 times the sine of 45 degrees divided by the sine of 77 degrees. Plugging those values into our calculator, we end up with B being approximately 10.1599. Now if we do the same thing for C, we know that the sine of 58 degrees over side C is equal to the sine of 77 degrees over side over 14. So if we solve for C, we end up with C being 14 times the sine of 58 degrees over the sine of 77 degrees. So C is 12.18497 approximately. So if we're going to put all of this together, we end up with a triangle where we know A, we found A to be 77 degrees, B was approximately 10.16, and C is approximately 12.18. So we were able to find the remaining sides and angles of that triangle. Let's look at the second case that we can run into, which is the law of sines, in which case we have the angle, angle, side situation. So for this situation, we're told that angle B is going to be 37.54 degrees. Angle C is going to be 34.39 degrees, and side C is going to be 5. So we know the angle, and then we know one of the sides that's not between the angles. So since we know two of the angles, we can use A plus B plus C is equal to 180 degrees to figure out the size of the third angle. And so angle A is going to be 180 degrees minus 37.54 minus 34.39. So angle A is going to be 108.07 degrees. If we go to the law of sines now, so that's going to say that the sine of angle A, which we said was 108.07, so the sine of 108.07 degrees over the length of side A is going to be equal to 34.39, so the sine of 34.39 degrees divided by the length of the side that's opposite, so 5. If we then solve for A, we see that A is going to be approximately 8.4157. If we do the same thing for B, so we can say that the sine of 37.54 degrees over B is going to be equal to the sine of 34.39 degrees divided by 5. If we solve for B, we see that B is going to be 5 times the sine of 37.54 degrees divided by the sine of 34.39 degrees, which gives us B approximately 5.3939. And so what does this triangle end up looking like? Well, we have angle A we found was 108.07. We found side A, which was about 8.42, and side B, which was 5.39. So now let's look at the law of sines for the side-side angle case. So for the side-side angle case, we have, suppose that we're given angle A will be 83.3 degrees. Angle B is going to be 9.1 degrees, or side B is going to be 9.1, and side A is going to be 11.8. So I drew it in this way because we know one of these angles, we know this side, but we don't know whether or not this is going to actually be a triangle. It may be one triangle, it could be two triangles, it could be that we have no triangle that meets these conditions. And so how do we go about deciding that? Well, if we want to look at it geometrically, we can kind of plug this situation into Geogebra. So let's see how that can happen. Okay, so here we are in Geogebra. So we want to construct just a general triangle. So I don't really need these X and Y axes. So I'll right click and get rid of those. So now I need a line segment that's a certain length. So I'll go up here and click the line segment of a given length, and I need that line segment to be of length 9.1. Okay, so I've got that thing, line segment of 9.1. Let's display the value of that. Geogebra is thinking. There we go. So I want the value of that showing up. Okay, so I've got a line segment of length 9.1. Now I need an angle of 83.3 degrees. So let's go to the angle. Let's make an angle of a given size. And so if we do that, we need an angle of size 83.3 degrees. So 83.3 degrees. Okay, so that gives us an angle. And now what I'm going to do is draw the ray. So let's draw a ray through our point A and our point B. Okay. So I don't need to see that value, so I'll turn off that label. And I don't really need the point B prime. Okay, so now I've got an angle that's 83.3 degrees. I've got a side that's 9.1. And then for the side opposite that, so my side A, the side that's going to be opposite that, has to have length 11.8. And so what I'm going to do is draw a circle with a given center and radius. So I'm going to stick my center of my circle at the other vertex, and I want the radius of that circle centered there to be my 11.8. So that whenever I do that, here's the picture that I have. Okay. Now, for every point on that circle, I am a distance of 11.8 units from that vertex B. And so wherever this ray that's coming off of here that has my angle of 83.3 degrees, everywhere this circle intersects, that ray gives me a triangle. So if I have this triangle from right there, so if I have this triangle, and I draw the line segment, if I draw the line segment from C down to B, I have one and only one triangle. And if I'm looking at it, so let's show the values that we have here now. So I want that value. So I have one side that's 9.1 units long. I have an angle that's 83.3, and I have the side that's opposite that angle of length 11.8. So this meets all the conditions that somebody has given me, and since I only have one intersection point with the ray that forms my 83.3 degree angle and the circle of length 11.8, it means that I only have one possible solution to my Law of Sines triangle. Okay, so what we've just seen from Geogebra is that for this particular triangle that we're going to have exactly one solution to it. So let's see how we might verify that kind of computationally. Okay. So we plug in the values that we know. We know angle A, we know the length of side A, and we know the length of side B. So from our Law of Sines, it tells us that the sine of 83.3 degrees over 11.8 should be equal to the sine of angle B over 9.1. Now if we solve for the sine of B, you see the sine of B should be 9.1 times the sine of 83.3 divided by 11.8. So if we plug those values into the calculator, then we get that the sine of B is approximately 0.7659193738. Okay, now comes where sine comes into play, because sine is positive in quadrants 1 and 2. And so if we've got angles of a triangle, our angles of a triangle can be any value between 0 and 180 degrees. And so this means that we could have two possible angles that each have a sine of 0.7659197738. So one angle in quadrant 1 and one angle in quadrant 2. So if we take the arc sine of that value, 0.7659197738, we take the arc sine of that value, we find that our first quadrant angle is going to be about 49.9888855 degrees. So it's about, we'll take it to be about 50 degrees. This means that our second quadrant angle is going to have a value of 180 degrees minus the value of our first quadrant angle. So we end up with a second angle in quadrant 2 having a size of 130 degrees. So we've got two possible angle values that could have a sine satisfied by the information that we're given. So now let's see why we know that we're only going to get one solution. Well, if we take the angle that we're given, so we're given angle A, and if we add on our second quadrant angle, this means that we get an 83.3 degrees plus 130 degrees gives us 213.3 degrees. Now that's bigger than 180. Since it's bigger than 180, that tells us that this particular triangle can't happen. And so we can't have any value where the sum of our angles is going to be bigger than 180 degrees. So what that tells you, because one case can't happen, we can and only have one possible solution. And that's our one solution is b is equal to 50 degrees. So that now if we have a plus b plus c is 180 degrees, we plug in 83.3 plus 50, and we see that angle C has to have size of 46.7 degrees. So back in our triangle that we were given, we know that angle B has to be 50 degrees, side B has 9.1, side A is 11.8, angle A is 83.3, and so now we have to figure out what side C is going to be. So for that we turn to our law of sines. We say that the sine of 46.7 degrees over side C is equal to the sine of 83.3 degrees over 11.8. This means, so if we solve for side C, we get C is going to be 11.8 times the sine of 46.7 degrees divided by the sine of 83.3 degrees, which, plugging that into the calculator, tells us that C is approximately 8.64677. So now, let's see what happens with a second case. So here's another situation with our law of sines. So we're given with our law of sines in the side-side angle situation, where we have side A is 41.5 degrees, side angle A is 41.5 degrees, side A is 8.7, and side B is 10.6. So again, this may or may not make a triangle. We aren't exactly sure yet. Okay, to see geometrically whether this will be a triangle, let's again go over to Geogebra. Alright, so let's go back to Geogebra again and see how many solutions we're going to have to this particular triangle. So again, I'll get rid of the set of axes, and I need a line segment of length. So let's see, I needed it to have length of 10.6. So 10.6 units long. And let's view that so we can actually see that length as we're doing it. So I want to be able to see the value that we have there. So it's a line segment of length 10.6. Now I need an angle. So I need an angle of a given size I need that size to be 41.5 degrees. 41.5 degrees. Okay. So now we'll draw the ray between those 2 points. Oops, no. I want the ray between point A and B prime. Okay. So I don't need that value. And I don't need to see B prime. Okay. So now I've got a line segment of length 10.6. I've got an angle of size 41.5 degrees, and now I need a segment for the opposite side to be of length 8.7. So again, I'll come back over to my circle. For my circle, I'll put it the center there at B. And I need the radius of that circle to be 8.7 units. So as I draw it, now again, every point on that circle is going to be a distance of 8.7 units from the side B. And so every point of intersection that that circle has with this ray gives me one possible triangle that will have the aspects of the triangle that I was given. It'll have angle A being 41.5 degrees, side B being 10.6, and side A being 8.7 units. And so I've got two possible answers in this case. I've got one answer there and one answer there. Okay, so if I do the segment between C and B, so there's one possible triangle. So with our one possible triangle, we'll say that side H, let's turn it on, see how long it's going to be. So we look at the value of that. So it's, oops. So it has, sure enough, it has length 8.7. And so I've got length 8.7. I have side 8.7, side 10.6, and the angle of 41.5. But then if I do the triangle between D and B, that also gives me a side of length pretty close to 8.7. I didn't find it exactly, but right at 8.7. And so I have another triangle there between A, D, and B as one solution, and A, C, and B as my second solution. So for this case of side-side angle, I'll have two possible triangles. So now let's see if we can find those algebraically. Okay, so from GeoGebra, we know that this particular situation is going to give us two possible triangles. Let's see if we can come up with those algebraically. Okay, so again, we go to the law of sines, we plug in what we know. So we know that the sine of 41.5 degrees over 8.7, so the sine of 41.5 degrees over 8.7 is going to be equal to the sine of B, which may be the angle up here, over the length of side B, 10.6. So solving for sine of angle B, we get the sine of angle B is 10.6 times the sine of 41.5 degrees divided by 8.7. So if we plug that into the calculator, we end up seeing that the sine of B is going to be 0.807330174. just like the previous case, this gives us two possible situations. We could have a quadrant 1 angle, and we can have a quadrant 2 angle as possible angles for our triangles. Well, for our first quadrant angle, if we just take the arc sine of 0.807331074, that turns out to have an angle size of 53.84 degrees. If we do the reflection of that triangle into the second quadrant, then angle B stays over here. It becomes the reference angle for our new angle. And so our second possible angle is going to be 180 minus that value of B. So a second possible value for B is 126.16 degrees. Okay. Now, just like what Geogebra told us, both of those angles, or both of those cases, are going to work. Let's see why both of those cases are going to work. So for case 1, we have what we're given. So A is 41.5, A is 8.7, B is 10.6, and we've said that we're taking the case where angle B is going to be 53.84 degrees. So sum of the angles of the triangle being 180 degrees tells us that angle C, in this case, could be 84.66 degrees. Going down to the law of sines, we've got that the sine of angle C over side C is equal to the sine of angle A over side A. So we get that the sine of 84.66 over the length of side C is equal to the sine of 41.5 degrees divided by 8.7. So if we solve for side C, we get that C is going to be equal to 8.7 times the sine of 84.66 degrees over the sine of 41.5. So plugging that into the calculator, we get approximately 13.0727. And so now for all 6 values of our triangle, we have angle A, which we were given as 41.5, side A of 8.7, side B of 10.6, and then we have angle B of 53.84 degrees, side angle C of 84.66 degrees, and side C of 13.07. Alright, so what about case 2? So for case 2, we have still our given values. So angle A is 41.5, side A is 8.7, side B is 10.6, and for our second case, we're taking our second quadrant angle of 126.16 degrees. And so this gives us kind of the obtuse triangle that we got here. 126.16, opposite side B of 10.6, angle A of 41.5, opposite side A of 8.7. So we plug in to A plus B plus C is going to be 180, and that gives us C having a value of about 12.34 degrees. Okay. Well, we go to our law of sines. So our law of sines in this case says that the sine of 12.34 degrees over the length of side C is going to be equal to the sine of 41.5 degrees divided by 8.7. So we plug those values in and solve for side C. We get C is going to be 8.7 times the sine of 12.34 degrees divided by the sine of 41.5 degrees. Plugging all that into the calculator, we get that C is going to be approximately 2.81 units long. Okay. So what this case gives us, so again, we have that, oops, let's make that a little bigger, so that our angle A, which we were given, was 41.5, side A is 8.7, side B is 10.6, and so we figured that angle B in this case was our 126.16. Angle C was going to be 12.34, and the length of side C was going to be 2.81. And so, because we have values for the triangle in this particular case, that's how we know that we've got two possible solutions in this case. So this is kind of taking you through several examples of the situations where we'll use the law of sines. Hopefully this will let you tackle your homework problems. See you guys later.